it has fuzzy search, whereas here I need to say PostgreSQL in order to get a page with the exact PostgreSQL hit. The previous results could take Postgres and kind of give me some other results. New vector database was basically the most closely related concept. So this is really good improvement. Django also has Postgres support, so I think this document might be having a higher similarity ranking. One of the problems with this plugin, though, is that it returns all documents. I think it's running the search result and ranking the documents. And you get all of them in a paginated result. But of course, when we're searching for something, we don't want all the documents to come back. We want relevant documents to come back. Even with pagination, it's a lot. And it's partially leading to slowdowns because there's probably some serialization that's going to happen. But I think there's another issue with the slowness, that it's not using indexing, which is another issue. So I was going to open feature requests, but I noticed there are already some feature requests for this, supporting a similarity threshold, so you only get the relevant documents above a certain score. And there was also one for the adding an index, which is also it has some challenges here because the length, I suppose the length of the indexes would have to vary. And I'm not sure, I've never really looked into PG Vector, but maybe when you define the index for a vector column, you need to define the column length, apparently. And different embedding models have different dimensions. So those are in the backlog already, so it's good to go. And I thought, well, maybe I'll try this similarity threshold, because that seems like one that's immediately relevant to this project. Both of them are kind of relevant. And I have no experience here, really no idea how this code is written, or my basic understanding of the concepts. So I'm going to try to use this Copilot Workspace on GitHub to see if I can get a little bit of an advanced understanding of how to write this feature. And essentially we're going to need to rely on multiple sources potentially for the embedding database. So there's Weaviate, Quadrant, and PG Vector, which have slightly different semantics. So what we'll do is we'll open this issue in Workspace, and I'm going to start just a new session real quick, just so you can see the whole thing from scratch. So actually, that's not quite what I wanted to do. So if I just open the Workspace, because I had a previous session, I just wanted to clear it out. It's going to read, it's going to generate a specification here. It takes the text of that issue, we want to normalize across backends. I'm going to see if I can supply some more context in our workspace to update the specification. Now, I'm going to do what's called meta prompting. I'm going to use a large language model to write a prompt for a large language model. And here I've got a chat going on with Claude, and it has in its context some discussion relevant to this project. So it already kind of knows some of the moving parts here about the indexing and the vector searching. So I'm just going to reuse this one. But I'd like to give Claude a little bit more information. I don't want to type a bunch. So what I'm going to do is just use ChatGPT to record my prompt for me. One issue I've noticed with the search interface is the vector search seems to return all documents, most likely ordered by vector similarity in descending order or ascending order, which is ever, I'm not sure. The most similar documents first, though I'm not sure if it would be a smaller number, smaller cosine distance. Regardless, it's a bit slow, and not all of the documents are relevant. So it's kind of not expected behavior for search results to include completely irrelevant documents or every document in a system. Rather, it would be nice if we could filter the results so only results that exceed a score are returned, a relevance score. There's already a GitHub issue for this, and I will paste the issue below. And I want to create a prompt using the GitHub issue to provide enriched details about it, the specific rationale, motivation, and considerations for implementing this. This prompt will be used to enrich the issue, and then in turn, a large language model will help develop the features. So I'm telling Claude kind of like what I'm trying to achieve. And I'm using ChatGPT. And then we're going to just take this, and now Claude already has a lot of detail. I'm going to see if it kind of picks up on the fact that I'm wanting a meta prompt. So now I'll create a prompt that enriches, there we go, the GitHub issue with more details about the rationale, motivation, and considerations for implementing similarity threshold in vector search results. This prompt will provide a comprehensive understanding of the feature request and guide the development process. This enriched prompt provides a comprehensive overview of the similarity threshold feature request. It explains the original GitHub issue by providing clear rationale and motivation to the feature, outlining important implementation considerations, identifying potential challenges, defining success criteria, suggesting next steps for development. And we got it over here. This expanded content will help guide the development process and ensure that all important aspects of the feature are considered. It also provides a solid foundation for discussions with the development team for creating more detailed technical specifications. Is there anything you'd like? Yeah, very good. So let's check it out. Currently, so we got some background, feature request, rationale and motivation, implementation considerations and potential challenges, and success criteria and next steps. So very thorough. This would be a good outline for a GitHub issue. So currently our vector search implementation returns all documents likely ordered by vector similarity. This approach can lead to slow performance and the inclusion of irrelevant results, which is not expected behavior of a search feature. Implement a similarity threshold for vector index methods, similar search and query. This threshold will filter out results below a similarity value, ensuring that only relevant documents are returned. It improves relevance, performance, and you can customize the precision. Aligns with user expectations that you will not have irrelevant results, consistency with other vector search implementations. Many vector databases already support this feature, indicating its importance in the field, so we're just kind of aligning with that. It has to support quadrant, PG vector, and Weaviate, which is why I pasted in the first comment. It was a great addition. Normalization. Consider if normalization is needed across different backends to ensure consistent behavior. So I think this is pretty comprehensive. We should always read, of course, and understand the output of these models before we just use it wholesale. But I'm just going to update the specification here and see what happens. It's going to analyze that, and we might get a richer plan, at least. The vector index class does not currently have those. It has methods that do not include a similarity threshold. The PG vector index mixing class and the quadrant mixing class do not implement a similarity threshold. The Weaviate mixing class also lacks support for similarity threshold. Okay, so that's good. Now it's identified the main mix-ins, and there may be other providers that are not in the list. So I'm going to just take a quick look under storage Weaviate provider. So let's check under the storage here. Similarity threshold. We'll open this, close this. Source, storage, NumPy, PG vector, quadrant, Weaviate. Okay, and NumPy provider. You know, I think the NumPy index mixin should be included in this for consistency. We want to be consistent. Dang it. I'll move these all the way to the right so I don't have to keep figuring that out. So it was a yes. The vector search now supports similarity thresholds for filtering results. Vector index class has been updated. Similarity threshold. PG vector class and the quadrant vector implement similarity threshold. Weaviate has been updated. The NumPy index mixing. Looks good. And we've updated the documentation. Okay, so I think we're getting kind of comprehensive here. So let's generate the plan. So it's going to check them out. Similarity threshold. Okay, so add similarity threshold parameter to query, find similar, and search methods in vector index class. Update the get similar documents and asynchronously get similar documents methods to accept the similarity threshold. So we're going to use this phrase, similarity threshold, and make sure it's consistent. So then we're going to look into PG vector, get similar documents, get similar documents, similarity threshold. Similarity threshold and get similar documents and get similar documents. Filter. Okay, so it's update the method to accept those parameters and then filter the results. So it's two steps there. You have to update the method, the signature, and then filter. Update filter. Similarity threshold is the same. Similar documents, similarity threshold is the same. And Wagtail NumPy get similar documents, similarity threshold is the same. Then we'll add some docs. Provide examples. Oh, that's really good, really good. And it's going to add a test index, similarity threshold parameter, and ensure the different backends, the tests cover them. Okay, okay. I think this is sounding pretty good. Let's see what it does. Wow. I mean, this has a lot of potential, this type of solution. And it really lets you stay at the level of like a kind of a product owner, project manager, senior developer trying to kind of lead a team and find solutions and ideate without having to get too low level in the syntax and implementation details. And then you review the implementation, of course. So you need that perspective at that point, and most likely test it. So one other thing, though, is illustrating the increasing importance of communication skills as these large language models begin to become more important in our daily work. So we can see the first file here has been implemented. It does add the similarity threshold with the default value of 0. So I'm guessing that's just everything. So maybe it's, I'm not sure if it's normalized. I haven't really looked into the specifics of the similarity threshold, but then we're using this. So we've got this query and get similar documents. A query then uses it and get similar documents. So the get similar documents is the crux here. Find similar uses get similar documents. Search uses get similar documents. And get similar documents, and all of it takes it, and then asynchronous get similar documents takes that, and it's not implemented in the base class, but it's there now in the API. So we're just going to look at that across now. PG vector provider. And it's, so we can see here it's passing it in, and then the query set fetch distance is true. So it has to know a bit about how we're querying it. So we want the distance, and if there's a distance specified, we want to filter by the distance less than or equal to that similarity threshold. So that's what I was kind of wondering, and I think it's it's cosine similarity, and it's talking about angles of distance. The closer or the items are, the smaller the angle is. So that's why we have this less than or equal to. Okay, up to that threshold. So then it's arbitrary, you know, but as close to 0 as possible. So that's actually pretty good, and we don't have to worry about normalization in that case. Interesting. What did it do here? Okay, so that's not good. It replaced parentheses with square bracket, so we'll have to fix that. I can actually just type. That's cool. Now this one's interesting. The numpy is greater than or equal to. If the cosine similarity is greater than the similarity threshold, it appends that result. But I think the cosine similarity here it should be less than or equal to. So let me And let's check the Weave8. NumPy, Weave8 provider. Let's just start with that question. You made an excellent observation, and you're right. The question is a discrepancy. Let's analyze the solution. Cosine similarity measures the cosine of an angle between the two vectors. It ranges from -1 to 1, where 1 means the vectors are identical. 0 means they're orthogonal. So you want it higher. -1 means they're opposite. What is the difference between orthogonal and opposite? Interesting. Yeah, well, it's vectors, so yeah, I don't know what that means semantically, like in terms of a meaning of a sentence. Huh. Interesting. For most applications in natural language processing and information retrieval, we typically deal with positive values 0 to 1. Okay, that's what I was thinking. Higher values indicate greater similarity, distance. Some vector databases, including PG Vector, often work with distance metrics instead of similarity. Common distance metrics like Euclidean distance have inverse relationship with similarity. Lower distance means higher similarity. Now let's look at the implementations. PG Vector, query set, filter, distance LTE, similarity threshold. This is correct. It's filtering the distances less than or equal to the threshold, which means it's keeping more similar less than 9. Man, this is so good. Both Claude and its ability to teach me this stuff, and the fact that GitHub Copilot Workspace just like generated the correct result. NumPy implementation. Cosine similarity greater than similarity threshold. This is also correct. It's keeping items with cosine similarity greater than or equal to the threshold, which means it's keeping more similar items. The key point here is that PG Vector is working with a distance metric, while the NumPy implementation is working directly with the cosine similarity. They're using opposite comparisons because they're dealing with inverse concepts. Distance versus similarity. Interesting. So we're abstracting it with our similarity threshold. But to make this clear and more consistent across implementations, you could consider the following. Rename the parameter. That's what I was actually trying to get at. Instead of similarity threshold, you could use distance threshold for PG Vector and similarity threshold for NumPy. But the problem is we have a generic interface. Normalized interface, yeah. You could internally convert the threshold for PG Vector to make the interface consistent. For example, similarity threshold is a float. If it's that, distance threshold, similarity threshold, depends on your distance metric. Distance, query set, filter, distance LTE, distance threshold. Yeah. That way you can use a consistent similarity threshold across all implementations, with higher values always meaning more similar. I like that. document it clearly. Make sure to document that for PG vector, the threshold is applied to a distance metric, while for NumPy is applied to a similarity metric. This will help prevent confusion for other developers. So yeah, let's go down to the PG vector. Yeah, and see we got distance also here. And just out of curiosity, what was Weaviate? Let's see. Similarity threshold. I do like the similarity threshold. You know, it's a positive number meaning more similar. I think that's a natural interface. So internally, we'll abstract that. So let's kind of scroll the whole page. All right, so let's start at the top. So we have all the consistent similarity thresholds, but we're going to introduce this. Whoops. Oh, I see. We're going to convert that. Then we're going to use that here, but we're also going to change the sign, change the comparison. No, we're not. Okay, cool. LTE distance threshold. All right, so then we also may need to do that for quadrant. In the PG vector case, we may also like PG vector, or just use distance based. And this is just basically, I'm opening this pull request to continue the discussion and see if we can get this feature implemented. You know, it's likely to be changed. Weaviate. It's a bit hard when there's so many things to scroll. NumPy, first quadrant. You're absolutely right. Implementing a consistent interface across all backends while handling their specific distance or similarity metrics internally is an excellent approach. Let's update the Weaviate and Quadrant implementations to use a similarity threshold in the public interface and convert it to the appropriate metric internally. Here's how we'll do each of those, 1 and 2. The modifications ensure that all backends use similarity threshold in their public interface, maintaining consistency. Each backend internally converts similarity threshold to the appropriate metric. metric, distance or score, based on a specific implementation. The behavior is consistent across all backends. A higher similarity threshold will always result in more stringent filtering, returning only similar documents. A few notes on these implementations. For Weaviate, we convert this similarity threshold to a distance threshold. Since Weaviate uses cosine distance, which is 1 over cosine similarity, we use this conversion. For Quadrant, we can use this similarity threshold directly as the score threshold, assuming Quadrant uses cosine similarity by default. If Quadrant uses a different similarity metric, this conversion might need to be adjusted. So lastly, we're going to look at the Quadrant docs there. In both cases, we only apply the threshold if it's greater than 0, maintaining the original behavior of not applying any threshold by default. To complete this implementation, update these. Okay, so let's check the Quadrant. Weaviate Quadrant score threshold. Define the minimal score for the result. If defined, less similar results will not be returned. Score of the returned result might be higher or smaller than the threshold depending on the distance function used. E.g. for cosine similarity, only higher scores will be returned. So it actually doesn't specify. We would have to specify the distance function. Excuse me. Okay, well, let me just paste in these to see if it affects the implementation. We want to just provide this again to Claude for shared context. Thanks for providing the documentation. The information is indeed crucial for the implementation. Let's analyze it and adjust our Quadrant implementation accordingly. The key points from the Quadrant documents are score threshold can be a number or null. So it's nullable. It defines a minimal score threshold for the results. The behavior depends on the distance function used. For cosine similarity, only the higher scores will be returned. Given this information, our current implementation for the Quadrant is actually correct. Here's why. All right, good. Quadrant uses cosine similarity by default, where higher scores indicate more similar vectors. Our similarity threshold parameter aligns with this concept. Higher values return more similar results. However, we can improve our implementation by adding some safeguards and documentation. Here's an updated version. Key changes. We've added a docstring to clearly explain the function parameters, especially the similarity threshold. We've added a check to ensure the similarity threshold is between 0 and 1, which is a valid range for cosine similarity. We've kept the direct usage of similarity threshold as a score threshold, which is correct for Quadrant using cosine similarity. We've maintained the behavior of not applying any threshold when similarity is 0. Wow. I do like the docstring. I would like to also consider adding docstrings to the other ones, get similar documents. Quadrant, similar documents. Convert the similarity threshold to a score threshold for Quadrant. With a cosine similarity, we can use the similarity threshold directly. If similarity threshold, if similarity threshold greater than 0, else none, because it's nullable. Okay. I like that. So this get similar documents is such a core function. We should really have a doc string for each of these, because there are some nuances in each one of them. This is the query set. And I guess Quadrant doesn't have an asynchronous get documents. However, Weave8 has only get similar. All right, so now we're getting towards the end of our chat, towards my context length. It's late in the day, so I'm not going to be worried too much about it. But what happens is every single message I send now, it sends the entire conversation. So I think one of the main things I'll ask is for help with this documentation. Documentation similarity threshold is good, but we can enhance it to make it even clearer and more comprehensive for developers. Here's a revised and expanded version. The revised documentation provides a clear explanation of what similarity threshold is and how it works. It includes code examples you provided, adds best practices and considerations to help developers use the feature effectively, includes a section on debugging and tuning, which is crucial for a feature that might require some experimentation. Mentions potential differences between backends, preparing developers for possible variations of behavior, I guess. Emphasizes the interaction between the similarity threshold and the limit parameter. Expanded documentation should give developers a comprehensive understanding of the similarity threshold feature, how to use it, and how to troubleshoot any issues that they might encounter. It also encourages thoughtful use of the feature by highlighting the need for experimentation and tuning. So we'll copy that. If you're not getting expected results, try lowering the threshold to see if more relevant results appear. Check the similarity. Somebody read over here, it'll be a little easier, but the vector search implementation supports a similarity threshold for filtering results. This feature ensures that only the most relevant documents are returned, improving both the quality of the results and query performance. All right, hopefully. Has that dual effect. I don't know if the performance will be impacted. That was my wishful thinking. Understanding the similarity threshold. The similarity threshold is a float value between 0 and 1, where 0 means no threshold. All results are returned up to the specified limit. 1 means maximum similarity. Only exact matches would be returned. Interesting. Values between filter results based on the similarity to the query. Higher threshold values result in fewer but potentially more relevant results. Similarity threshold in vector models. The vector index class includes similarity threshold parameter in methods like query, find similar, and search. And it shows the code there. Example usage. Here's some examples of how to use it. Query index. What's the capital of France? Similarity threshold 8. So yeah, similar objects 7 and floating points. Best practices. Consider choosing a threshold. Start with a lower threshold, e.g. 0.5, and adjust it based on your specific use case and the quality of results. Higher thresholds can improve the query performance by reducing the number of results processed. Maybe. Result set size. Be aware that higher thresholds might significantly reduce the number of results. Always check if your result set is empty and consider lowering the threshold if necessary. While we strive for consistency, different vector search backends like PG Vector, Quadrant, and Weaviate might have slight variations in how similarity is calculated. Test thoroughly with your specific backend. Yeah. Combining with limit, the similarity threshold works in conjunction with the limit parameter. Results are first filtered by the similarity threshold, then limited to the specific number. Debugging and tuning. If you're not getting the expected results, try lowering the threshold to see if more relevant results appear. Check the similarity scores of your results, if applicable. To understand the distribution, consider the nature of the data in your queries. Some domains might require lower thresholds to capture relevant semantic relationships. This is an interesting one. I would like to request a feature, if it hasn't already been requested, to return the similarity scores. Something like get annotated documents, something like that. Because I think we're just returning the results directly without any annotations on that. We're losing the similarity scores, and that could be useful for many use cases, including might be something you would display in the user interface. So it has some tests. So the query is calling a chat backend. I'll just have to kind of trust these tests. And Claude's not going to have enough context here to really validate these for me. So I'm going to go ahead and create a pull request with this. They may have continuous integration to run this test automatically. And if the tests fail, then I'll take it to the next step. I haven't even set up in a development environment. The key is I wanted to try the Copilot Workspace. And once we have the pull request open, I can open that. I can actually open it in a code space here to run the tests. I should have done it. Copilot session, share ID, create a pull request. Let it to 21. Let's go ahead and create the pull request. It's getting a bit late. I'm kind of tired. I've had a long day at work, and just want to kind of move this conversation forward with some actual code to discuss, implementation to discuss. But if I do open the code space, I might be able to run the tests here in the code space. And by conversation, I mean the GitHub ticket has the original request, which I thumbs up, I voted up because I'd like to support that. And they did take a quick look at that and just added some notes. So I was like checking those out. So now I can open this pull request as a way of commenting in a way to say, hey, here's a hypothetical implementation with the help of these large language models. And it's opening a code space still. So and I'll check if there's a CI pipeline. It does appear there is, but it's not running the tests. Okay. So how do I run a test if I want to test this? So development, pre-commit, I can run the test. Talks. Flit, huh? Some of them are using Flit. Python. Simple way to put Python packages and modules on PyP. Okay. It tries to require less thought about packaging and help you avoid common mistakes. Okay. Makes sense. And this is a package on PyP, so I can see why they have that method. But what we'll do is we're going to have this code space running, and then I will install the dependencies with pip. May or may not run pre-commit on these, and talks to run the tests. All right. The code space seems to be running now. Setting it up. So this is another really cool thing. You just have VS Code running in your browser on a remote machine with all the code in a Python environment ready to roll. And all the open source projects I do now, I set up what's called a dev containers definition. They have one here. And because they have a dev container, then VS Code just knows, hey, when you open this project, there's a Docker Compose it's a Python project, so install these extensions. And some other great stuff. Let's see what their Docker Compose says. Python Bullseye, cached. And I think we can just do a pip, oops. Paste it. Did I paste it? Allow it to see. Okay, Flit, I had that in my clipboard. Okay, so it might still be thinking about it. Sometimes there's a post command. This one doesn't appear to have, post create command is going to pip install talks and talks dev. Okay, so then it's going to handle that for me. I just need to wait. It's a little bit slow to start up. But I think this is really such a useful thing, particularly if you've got an open source project that might have contributors who are various skill levels, or even yourself, and you don't want to worry about what it is to get the development environment set up. Are there any low-level operating system dependencies you might need to compile Python wheels or anything like that? See, it just automatically runs the installation in your Docker compose in Docker file. You can have operating system dependencies that you might need for your project. And the developer just doesn't have to worry about any of that. They can just get in there and start working on a feature. Honestly, the development environment has been one of the biggest barriers to entry I've noticed in open source in particular, just getting something set up. And we just this week, I'm working with a couple friends, and we meet once or twice a week to do review sessions and stuff. And honestly, it's not always easy to do peer review in a constructive way. And so there might be some issues with communication, but we froze, and we're unable to get the development environment set up. Just a Python virtual environment opening in VS Code. It was just such a barrier to entry. It was really eye-opening for me, and a reminder of how difficult seemingly simple things can be when you just take them for granted. So really making the developer experience as smooth as possible, I think, is a very important goal. So now we can run talks, I think. Just going to run the tests. Language is MIT. This is MIT. All right, well, these tests are going to take, I guess, a little bit to run. We're at 1 hour in. I can wait a few more minutes to see if these tests run, pass or fail. I probably won't try to fix them tonight. Okay. All right, so that's test query passes sources to backend. So let's go to the testing interface, configure the Python tests. I guess we're using PyTest. Yep. So we don't have the PG Vector module installed. Yeah, I had a lot less confidence that the test would run. It's not the most exciting part of the pull request either. Damn. So we just run the first series of tests and not the whole everything. Okay. Test query, type error, local, get some of the documents. Whoa. So I think we're just mocking the function here, and we're returning some documents. So it's making sure that it passes the right thing to there. And our mock function here didn't have the argument. I believe that's the problem. No data was collected for, wait, sorry, where's the other one? Element counts were not equal. So there's actually a failure. And I'm not going to be able to take the time to fix these. Currently, I'm really getting tired. I want to I'll commit this change though. What about the unequal numbers? I think Copilot Workspace didn't do such a great job of writing the unit tests. Those were pretty complicated. I'll probably use Claude to help me with those. Let's see, kill this. Just to see if the problem went away though with the first error. Oh. Yeah, element counts were not equal, so that's good. So yeah, I'll just commit this change right here under the get similar documents under test query passes sources to backend. All right, so let's go to the pull request. Here in the tests, oh, okay, there it is. Ah. Right. It's causing breaking in other tests. Okay, that makes sense. Size 1 improvement. So yeah, I'll come back to this pull request probably tomorrow. And clearly it has failing tests. I'll just make note of that. Convert it to draft to indicate it's in progress. Cool. All right, it's been a session of Tech with Briley. We've been contributing to the open source Wagtail Vector Next project, trying to take one of the feature requests to support specifying a similarity threshold. There's a bit of nuance to it because of this project. It supports multiple vector storage engines, and each of those has slightly varying similarity metrics or distance metrics that they use. So we had to provide one unified interface to multiple distinct backends. All right, well, I hope you're doing well. Have a great day.